When it comes to winter forecasts, one term dominates the conversation: La Niña. This climate phenomenon is often the wild card that meteorologists and weather enthusiasts watch closely as the colder months approach. Its influence can be felt across continents, shaping everything from snowfall totals to temperature swings, and even the timing of winter storms. La Niña is a natural climate pattern marked by cooler-than-average ocean surface temperatures in the central and eastern tropical Pacific. These vast stretches of cool water are visible from space, and they set off a chain reaction in the atmosphere that can ripple around the globe. This cooling shifts air circulation patterns, alters the path and strength of the jet stream, and helps steer storms and cold air masses across North America. The result? Dramatic changes in weather, with some regions bracing for relentless storms and others experiencing milder, drier conditions. La Niña, which means the little girl in Spanish, is the cold phase of the El Niño Southern Oscillation, or ENSO cycle. Its counterpart, El Niño, is the warm phase, and together they form a powerful duo that drives much of the world's year-to-year climate variability. During La Niña winters, the jet stream typically strengthens and takes a more northern route, flowing from west to east. This often means more frequent and intense storms for the Pacific Northwest and northern U.S., bringing heavy rain, mountain snow, and colder temperatures. Meanwhile, the southern U.S. tends to stay drier and warmer than usual, sometimes leading to drought concerns. But La Niña is just the starting point. Other factors, like Arctic oscillations, sudden stratospheric warming events, and even lingering effects from previous seasons, can amplify or disrupt its influence. That's why no two La Niña winters are ever exactly alike, and why each season brings its own surprises. Forecasting a La Niña winter is a complex challenge. It's not just about whether La Niña is present, but about its specific characteristics, like how strong it is, how long it lasts, and how it interacts with other climate drivers. Meteorologists rely on advanced models, historical data, and real-time observations to make their best predictions. For winter 2024-2025, we're heading into a confirmed La Niña event. But this year's La Niña isn't following the textbook pattern. Its development has been unusual, and forecasters are watching closely to see how it evolves in the coming months. The details matter: where exactly the Pacific is cooling, how strong the event becomes, and what other global climate factors are at play. All of these will shape the final outcome for winter weather across North America and beyond. So, what makes this La Niña unique, and what could it mean for you and your community? Let's break it down and explore the possibilities for the season ahead. Many people assume there's such a thing as a typical La Niña winter, expecting the same weather patterns to play out every time this climate phenomenon appears. But the truth is, La Niña winters are far more unpredictable and volatile than most realize. The idea of a standard La Niña season is more myth than reality. While long-term averages suggest the Northwest should be cold and wet, and the South should be warm and dry, these are just broad generalizations. The actual weather can be dramatically different from year to year. In reality, La Niña winters can swing wildly, with some years bringing record-breaking snow, and others delivering mild, almost spring-like conditions. No two La Niña winters are exactly alike. Take Indianapolis, for example. Over the last 9 La Niña events, the city experienced 4 winters that were colder than normal, 4 that were warmer than normal, and just 1 that was close to average. That's a huge range of outcomes, all under the same La Niña label. The reason? La Niña alone doesn't guarantee any specific outcome. It's just one piece of a much larger climate puzzle, and other global patterns play major roles in shaping our winter weather. Think of La Niña as the lead singer in a band, setting the tone and grabbing the spotlight, but the rest of the band, other climate drivers like the Arctic Oscillation, Pacific Decadal Oscillation, and even random weather events can change the song entirely, sometimes in unexpected ways. So, instead of asking, what does a La Niña winter mean, and expecting a simple answer, the better question is, what kind of La Niña winter will this be? Because every year brings a unique combination of factors. To get a clearer picture, we have to dig into the specific characteristics of this year's La Niña, how strong it is, where the coldest waters are, and what other climate patterns are doing at the same time. We also need to consider the state of other global drivers, which can amplify, mute, or even reverse La Niña's typical effects. Only by looking at the full picture can we move beyond the myth of the typical La Niña winter and get closer to understanding the true reality and the real possibilities of the coming season. Not all La Niñas are created equal. While the term La Niña might sound straightforward, the reality is much more nuanced. Each event can look and behave differently, and understanding these differences is key to predicting their impacts. The effects of La Niña depend on where the Pacific Ocean is coolest. The location of the coldest water shapes weather patterns across the globe, influencing everything from rainfall to temperature extremes. There are two main types of La Niña events. The first is eastern-based, where the cooling is concentrated near the coast of South America. This type is often associated with dramatic shifts in weather, especially for the Americas. The second is central-based, with the coolest waters near the international dateline. This subtle shift in location can lead to very different weather outcomes, even if the overall ocean temperatures look similar. Eastern-based La Niñas often trigger high-latitude blocking patterns, which can send frigid Arctic air plunging deep into the United States. This setup is notorious for fueling major snow events and prolonged cold spells, especially in the Midwest and Northeast. In contrast, central-based La Niñas tend to favor a ridge of high pressure over the southeast. This keeps the southern states warmer and drier, while the north and northwest experience colder, wetter conditions. The difference in impacts can be dramatic from one region to another. But there's also a third, more complex type, the mixed or basin-wide La Niña. Here, cooling spreads across much of the Pacific, rather than being focused in one area. This hybrid pattern doesn't fit neatly into either box. It can blend characteristics of both eastern and central types, making its impacts harder to predict and often more variable. For winter 2024-2025, we're seeing this mixed basin-wide setup. The Pacific is showing signs of widespread cooling, which adds a layer of uncertainty to seasonal forecasts. These mixed events are notoriously difficult to forecast. They can increase the risk of cold outbreaks in the eastern U.S., but also bring surprises elsewhere, challenging even the most experienced meteorologists. That's why understanding which type of La Niña is in play is crucial. It helps forecasters anticipate not just temperature swings, but also shifts in precipitation, storm tracks, and even drought risk. This year's mixed La Niña sets the stage for a complex and unpredictable winter, where staying informed will be more important than ever. The upcoming winter's La Niña is weak to moderate and mixed basin-wide. Cooling is spread evenly across the Pacific. This prevents us from relying on past eastern or central-based analogs. A weaker La Niña means it won't dominate, allowing other climate drivers to influence the outcome. Historically, these mixed, weaker events bring volatility, temperature swings, and active storm tracks. Past analog years like 2005-06 and 1995-96 saw major winter storms and variable conditions. Expect a battleground pattern, with mild spells interrupted by sharp Arctic blasts. The storm track could be especially active through the nation's midsection. By studying these analogs, we see the potential for persistent cold over Canada and frequent storms. This winter's unique setup promises surprises and variability. With a weak, mixed La Niña, other climate drivers become crucial. Three key players: the quasi-biennial oscillation, QBO, Pacific Decadal Oscillation, PDO, and Indian Ocean Dipole, IOD. The QBO, now in a negative phase, weakens the polar vortex, making Arctic air outbreaks more likely. The PDO, also negative, supports a ridge in the North Pacific, steering cold air into central and eastern North America. The IOD, in a negative phase, subtly reinforces cold air sources over Canada. Together, these patterns set the stage for a winter with frequent cold shots and active weather. Their combined influence will be critical in shaping the season. The negative QBO could be a game-changer this winter. It disrupts the polar vortex, making it more likely to wobble and send Arctic air south. A weak polar vortex, nudged by the QBO, can trigger sudden stratospheric warming events, unleashing frigid air into North America. This setup favors a negative Arctic oscillation, which helps dislodge cold air from the poles. Expect dramatic temperature swings, mild spells punctuated by intense, week-long Arctic outbreaks. Unlike the relentless cold of 2013-14, this winter will likely feature high-impact cold snaps rather than a season-long deep freeze. The QBO is stacking the odds for memorable cold events. The interplay of these factors means volatility is the theme. Prepare for rapid weather changes and headline-making cold waves. While the QBO primes the atmosphere, the negative PDO and IOD reinforce the cold pattern. The negative PDO encourages a ridge in the North Pacific, blocking mild Pacific air and steering the jet stream south. This jet stream setup delivers Arctic air into the US, especially the Midwest and Northeast. A persistent Hudson Bay low acts as a reservoir for cold, fueling repeated cold shots. The negative IOD supports blocking patterns over Alaska and Greenland, further disrupting the jet stream. When La Niña, QBO, PDO, and IOD align, the result is a powerful tilt towards significant cold outbreaks. This rare alignment is setting the stage for a memorable winter. The synergy of these drivers can't be ignored. So, what does this mean for your region? Expect a persistent cold source over Canada, with the core of cold repeatedly targeting the north-central US. The main storm track will run from the Midwest through the Great Lakes and into the interior Northeast. The upper Midwest and Great Lakes are in line for a colder, snowier winter. Think classic old-fashioned storms. The Northeast will see wild temperature swings, with the interior likely to get above-average snowfall. The I-95 corridor could see big snow storms, depending on storm tracks. The South will be shielded by a high-pressure ridge leading to a warmer, drier winter. Occasional cold fronts may reach the Gulf, but sustained cold is unlikely. The Pacific Northwest can expect a colder, wetter winter with heavy mountain snow. This pattern promises a dynamic, high-impact season for much of the country. Recent winters have been mild, especially in the east, but this year looks different. While not as brutal as 2013-14, this winter could be colder and snowier for the northern US than we've seen in years. The rare alignment of La Niña, QBO, PDO, and IOD points to a more impactful season. The cold source will be firmly over Canada, with a protective ridge over the deep south. Expect a warmer Gulf Coast, but a colder upper Midwest and Great Lakes. The active storm track is a shift from recent dry winters. This winter proves why we can't rely on a single indicator. Secondary drivers are co-pilots this year. Get ready for a season of volatility, surprises, and classic winter weather.